In this video, we're going to be looking at sigma notation for a geometric number pattern. Okay, how did I know that this is a geometric number pattern? I looked at the variable. They say the variable is k. When I look at the variable on this Tn formula, I see that it's an exponent. So this part here, it's always your Tn. So this is your Tn. So if the variable is an exponent, you know that your pattern is geometric. Okay, so let's analyze this pattern. So they're saying we need the sum. Remember, sigma means sum. So I already know I'm going to use this formula. Sn equals to a r to the power n minus 1 over r minus 1. Right? Because I'm looking for the sum of 6. I mean, from 1 up until 6. So basically, let me break this one down so that you see what this means. So basically, they mean we're moving from k equals to 1. And then we're going to go to k equals to 2, k equals to 3, 4, 5, then 6. So this is where you are starting. That is where you are ending. Right. And I always like to substitute the first two terms here. Né? So I'm going to substitute k1 there and see how much you got. So I'm going to have 32 in bracket. Then I replace the k with 1, then we have a minus 1. Then you can see that T1 in this case is going to be 32. Right. Now let's do the second term. T2 will be 32. So you just write the same thing basically, but you put 2 there. And then let's see what does this give us. I think that should be 16. But let's just press on a calculator to verify. Then gonna be 2 minus 1. Yes, that's 16. Now we are sorted. We can easily find everything there. You can see that A, it's always the number that you get when you substitute the first part. So we got 32. So that's our A. Ne? A is the first number on the sum. Sharp, the first term of the sum. Right. Then we can easily get R. Remember, the ratio is T2 over T1 of geometry, right? The second term is 16. The first term is 32, which is half. So our R is half. And then how many terms are we adding? We're adding 1, 2, 3, 4, 5, 6 terms. Ne? But this is not an efficient way of counting how many terms you are adding. I'll show you the best way to do it. Ne? So n, it's always calculated in this way. You take the top number, which is 6. You minus by the bottom number. So it's top minus bottom, and then you add 1 always. So you take the top number, you minus 1, and then you add 1. Always top minus bottom plus 1. That is your n. So in this case, it's 6. Right. Now we can easily substitute everything into the formula. We're looking for the sum of 6 terms. So I'm going to say S6 is the same as, let's move a little bit this side. Our A equals to, our A was 32 in bracket. I like putting my R in its small bracket. So our R was half to the power 6 minus 1 all over. Our R is half minus 1. And then let's press that on a calculator and see how much it gives us. So our A is 32. Our R is half to the power 6 minus 1. And then we close a bracket. At the bottom, we have half minus 1. That gives us 63, which means the sum of the first 6 terms of this pattern gives us 63. Okay, let's get to the next one. Don't forget to hit the like, share, and comment button and subscribe to the channel, ladies and gentlemen. Let's help this channel grow and reach more people. The more you like, the more people it reaches. Okay, so let's check this one. Use the general formula for the sum of a geometric series to determine K. Okay. So now, we already know that is geometric because our variable is n, and n is an exponent. So we know that is geometric. So we can easily see n is going to be top, I said is the top number, which is 8, minus the bottom number, which is 1, and then you add 1. This is 8, so our n is 8. Okay? And then they gave us what this sum is equals to. They said this sum is equals to that. So they gave us that the sum, remember we know the n is 8. So I can say sum of the 8 terms is basically 2, 5 over 64. So 255 over 64. This doesn't look nice. Let's write a nice 5 there. Sharp. And then remember I said I prefer to get the first 2 terms or 3 terms. No? So I can see that I'm starting at n equals to 1, then it's going to be 2, then I'll just stop at 3. Actually, let's just do the first 2. No? It's easier. So I'm going to say T1 is the same. Remember, this part here is your Tn. It's the same as k to the power half and then 1. You can see that this is basically half k, which I prefer to write this way as k over 2. If the whatever is on the side is a numerator, so it goes at the top sharp. So it's like here you have over 1. This times that gives you that. This times that gives you that. Then let's get the second term. Now we found the first, let's get the second term. T2 will be k half, we substitute 2 now on n. Then that will give us 1 over 4 with a k here, which is basically k over 4. Right. And then the first 2 terms will help us to get a. This is our a, right? Is the first term. It's k over 2. Then let's now get r. Let's now get r. So we can see that, okay, r is basically T2 over T1. Term 2 is basically k over 4 divided by the first term, which is k over 2. This will give us k over 4. We change the divide to multiply, and then it's going to be 2 over ku t times. The answer is half. So your k is half, ladies and gents. And then I'm sure they will want us to solve for k, right? Yes, determine the value of k. Okay, that should be fine now. We have Sn equals to a. Remember, I'm using geometric because it's a geometric number pattern. Did they even say? Let's go check on top if they told us. Yes, they told you there. But most of the times, they don't tell you. Don't depend on them to tell you. Ne? You must see it here. If the variable here is an exponent, is geometric. Okay, thank you. So our a, it's half k. Okay. So there I'm going to have, let's see. I'm going to write it here. It's going to be, what is the Sn? The Sn is 225 over 64. So I have 255 all over 64 is equals to my a, which is half k, right? Then we multiply the a by r, which is, I prefer to put the r inside there, and then it's going to be to the power 8, because our n is 8, then minus 1, all over half minus 1. I'll just do this. Ne? Sharp. So now we can easily solve for k. We are going to do this. Firstly, I can multiply both sides by half minus 1, right? Even that side by half minus 1. So I always multiply by the denominator. This will cancel that. Let's see what does that gives us in the calculator. So you have half minus 1 in bracket, and then you have multiplied by 255 over 64. And that gives us negative 255 all over 128. Okay. And then we are left with k over 2. Actually, we can write it this way. Half in bracket to the power 8 minus 1. That is our a. And then I'm going to multiply by 2 both sides. So multiply by 2, multiply by 2, so that this 2 will cancel with that one. Perfect. And then we can now easily see that, okay, I'm multiplying by 2. So whatever answer I have, I'll say multiply by 2. I have negative 225 over 64, which is equals to k. Then you have a half to the power 8 minus 1. Obviously, since I'm solving for this guy here, and here there's no any other variable, I'm going to divide both sides by that. Right? Sharp. Or simply I can say I'm multiplying by 1 over that. So 1 over 2. It's like you're dividing both sides by that. Ne? So even here 1 over half to the power 8 minus 1. Sharp. This one will cancel with that one. That side you left with k only. And then we can see that, okay, k will be equals to whatever we get there. So whatever answer we have, so I'm going to say ans multiplied by 1 over 2 brackets, half close bracket to the power, or to the power 8, ne? Sorry, not 2. So this is to the power 8. To the power 8, then minus 1. And then there. Then k equals to 4. Okay, perfect. And then let's do the last one, ladies and gents, of this section. Sure. I advise you to pause the video and attempt this question to see how much you understood so far. Right. And remember, if you're just watching this video without watching other videos in this playlist, I advise you to go under playlist and start from the beginning and advance with the playlist. Okay. Let's proceed, ladies and gentlemen. So here they say a geometric series. Remember, series means sum, right? So I already know that I'm using Sn equals to a r to the power n minus 1 all over r minus 1. Right. And then I'm given that the first term is equals to minus 4. I'm given that the fourth term is equals to 32. They want me to determine the value of r and n if the Sn is 84. Okay. So guys, here I'm given 2 terms, right? Let's come and work here first. So I have term 1 and term 4. Right. I'm going to use this technique. Ne? It's called the division technique, ladies and gentlemen. This is your first equation. That is your second equation. And you are going to do this ratio always if you're working with a geometric number pattern. So the bigger number is 32 in this case. So we're going to say equation 2 divided by equation 1. You take the bigger one, you divide by the smaller one. So you're going to have T4 over T1. So T4 over T1 is the same as 32 over minus 4. Right? And then let's keep on going. Remember, this is a geometric number pattern. We know that Tn is the same as a Rn minus 1, right? This is the formula of the nth term or the general term of this pattern. So now we can easily take this 4 and substitute there. So for term 4, we are going to have a to the power r4 minus 1, which is 3. Remember, you put 4 here and there. And then term 1 is going to be a to the power r to the, a times r to the power 0. you can see because here is going to be 1 minus 1. Sharp. Now you can substitute this in here. You have AR to the power 3 over A, because this will simplify to A times 1. Anything to the power 0 is 1, then you get A. Sharp. And then you get, what is 32 divided by negative 4? Let's see. 32 divided by negative 4 is negative 8. Ladies and gentlemen. Then this A, you can see it will cancel that. Then we have R cubed equals to negative 8. Then we are going to cube root both sides. So cube root there. We cube root there. Remember, you need to remove the exponent by the root. So R is basically negative 2. Right. And then now we can easily get what A is. Ne? Sure. So we know that R is negative 2. Actually, A is negative 4 because they gave us the first term there. So we are sorted. Right. Let me just write them here because we'll need them. R is negative 2. A is negative 4. Okay? Sharp. Now we can go and solve. Now on this one here, you have 84. So you put 84 there. On the Sn, your A is negative 4, which is the first term. And then your R is minus 4. I mean, minus 2. Always put your R in bracket, ne? Especially when it's in negatives, because if you don't, you are going to have an issue. We don't know what n is, so I'm going to have that. Then I'm going to have minus 1 all over negative 2 minus 1. We can see that negative 2 minus 1 is negative 3. So I'll just say all over negative 3 to save time. All right, because R is negative 2 there. Sharp. So now, to remove the negative 3, since it's dividing, I'm going to multiply by negative 3 both sides. So let's see. Negative 3 times 84. That is negative 2, 5, 2 equals to negative 4 in bracket minus 2 to the power n minus 1. And then, since negative 4 is multiplying, I'm going to multiply by its inverse. So I'm dividing by negative 4 both sides, basically like that, you see? So this one and that one will cancel each other. So what is negative 252 divided by negative 4? That gives us negative 63. That gives us, positive 63, ne? Positive 63 equals to negative 2 to the power n minus 1. So we're left with that part. And then if you take 1 that side, we can all see we're going to have 64 now, because 63 plus 1 is there. And then you have there. And then now you can do this. 64, you can say on your calculator, 64 equals to, and then you press shift. And then you press fact. Fact is that thing with a lot of decimals like this, you see? It's on B. So you press fact, you get 2 to the power 6. Then this side you have negative 2 to the power n, right? And then now the good thing is, if the exponent is even, it doesn't matter what the base is. For example, this 2 to the power negative 2 to the power 6 is exactly the same as 2 to the power 6. These are going to give you the same exact answer. So we can conclude that the bases cancel, therefore n equals to 6. And that's finito with this video, ladies and gents. Please don't forget to like, advise your friends, your classmates to come and watch the videos for Maths Fanatics 24/7. Let's build a community of Maths Fanatics 24/7. Thank you very much, ladies and gents. Aluta kontinua. Tango.